going to finish up chapter 7. Our main goal today is actually not graphing the square root and radical functions, but we'll be using our graphing calculator to graph them for us. And also we're going to find the intersection of two equations or two functions. We also are going to be rewriting some square root functions so that we can actually describe the transformation that's going on. How is it being shifted? How is it being stretched when it looks a little different than some of the ones we saw yesterday. So the directions for numbers 9 and 10 all say to use the graphing calculator. So we're going to do that first. I am going to show it algebraically because I think you should know how to do it. Many of you will like the algebraic method better than the graphing calculator, but I want you to be able and comfortable with doing both. So number 9 says we can model time t in seconds of an object as it takes to reach the ground falling from a height h in meters. So they give us this equation. So t of h is representing the time, h is representing the height, and then they actually tell us what g is, which is our 9.81 meters per second. So we're actually going to plug that in. Then it says, use a graphing calculator to determine from what height an object falls if it takes 7 seconds to reach the ground. So 7 seconds, that means time is 7. All right, so if we're using the graphing calculator, what you're actually going to do is you're going to graph two equations. I don't want to say two lines because one's a curve and one's a line. But we're going to graph two equations, and then we're going to look for the intersection. Of the two graphs. Okay, so in our graphing calculator, in our y1, we will put in this equation, obviously plugging in the 9.81. So in the calculator, we'll type our square root, and it'll be parentheses 2. Now instead of h, our graphing calculator, we have to put in x. Now if you wanted, you could actually put an extra set of parentheses around the 2x. However, multiplication and division will go in order from left to right. So the graphing calculator will do that for us. Now in y2, the other equation we're going to put in is actually just a constant function, just y equals 7. So when time equals 7, when y equals 7. And we're going to see where these two things intersect. So on our graphing calculator, we'll go and figure out anything in our y equals. We'll type in our square root, maybe, 2x divided by 9.81. And in y2, we'll put equals 7. And then, of course, we always want to start with Zoom 6. As our standard. And we should see, obviously, here's our y equals 7, horizontal line. Slope of 0, and here is our square root function. You can see it's just really slowly increasing. So we're going to have to modify the window to be able to see what's going on. You can try zooming out, and sometimes it is successful, but the window can be much more useful. So we're going to adjust the window, pressing the window button, of course. What do you think I need to change in order to see the intersection? Because the intersection is going on somewhere over here. Good, I need to change the x max. We don't know what to change it to. It's trial and error. So I'm going to press my window button, go to my x max, which is right now at 10. I'm thinking it needs to be substantially bigger than that. I might go with 100, just because I saw how slow that curve was increasing. So let's try 100. Do not press Zoom 6 again, just press graph. And you can see I'm almost there, but not really. So go back to your window, change it even bigger. Let's go 500. Just a guess, I don't know. And that's good. You can see the curve coming up and going through the line y equals 7. Now, who remembers how to find the intersection? Bree?
Second trace.
Good. We're going to press second trace and option 5. Now, it asks you several questions at that point. Move this over here. So second trace, we press option 5. It's going to ask you first curve, second curve, and guess. You can just hit enter, basically, for 2 out of the 3. Because you only have 2 curves, so your calculator will automatically distinguish between the 2. The only reason it asks you this is in case you had 5 curves, they'd want to know which 2 are you talking about. So when they say first curve, just hit enter. When they say second curve, just hit enter. And when they say guess, bless you, we will try to get as close to that intersection point as possible. We should get 240.345, and our y value is 7. So let's just round that to the nearest whole number. So let's say 240. And that would be, units of height is in meters. So 240 meters. Now, in contrast to the graphing calculator, if you want to do this algebraically, what you would actually do is just take 7 and plug it in for time in the equation. So you would get 7 equals the square root of 2h over, and remember we plugged in 9.81 for g. And then we would solve for h. How do I solve that algebraically?
Wouldn't you need an h equals 7 too? It says like of an equation it's t times h.
It's t, that's really t of h.
Okay.
Like f of x. So like a function in terms of x. So this is time in terms of the height. So it's not multiplication, it's just a function. So really we're plugging in just 7 for the time, which is the whole thing. But how would I solve it once I plug it in? Lainey?
You have to square both sides.
Good, square both sides. And then you guys know how to solve from there, right? Multiply by 9.81 and then divide by 2. And we should get the same answer. Space over here. Obviously, a lot of students will think this is much easier, but I do want you to be able to do it both ways because you will be needing to use your graphing calculator a lot in your future math classes, so it's good for you to get comfortable. Now, for part B, they just want us to change, instead of time being 7, time is 3.5. So what I'm going to do is I'm going to go to my y2, and I'm going to change it to 3.5. So if I'm using the graphing calculator, go to my y2, change that to 3.5. Do not press zoom 6. If you do, you're going to have to modify the window again. So if we just leave it as is, just press graph, it's going to keep the window the same, and it should be good enough for us to see. So again, looking for that intersection, we'll press second, trace, and option 5. First curve, just hit enter. Second curve, see how it moves automatically to the other curve. Just hit enter, and then do your guess. You do want to get as close as possible. And we should get 60.08625, so let's just say 60. Then it asks us, how do the distances in part A, and that should say B, how do the distances in part A and B compare? So obviously some people will be like, well, part A is bigger than part B. Part B is smaller than part A. Those are both correct statements. But is there something that we notice in general? Because the time, we cut the time in half, right? 7 divided by 2 is 3.5. Did we cut the heights in half? No, what's the relationship between 240 and 60? Evan?
It's 60 times
Good, 60 times 4 would get me 240. So when we cut the time in half, the height actually got divided by 4. Okay? We can even say divided by 2. The height was divided by 4. And then that has to do with the idea that you are square rooting 2 times the height, all divided by your g, which is your gravity. So when you take the square root of 4, that does get you back to 2. So that's kind of how that relationship is showing up. All right, now number 10, I'm going to start you off on it, and then I'm going to have you guys finish it up. The only reason I'm not letting you do this on your own is that the variable this time is actually 2 variables, but it's representing 1 unknown. So this one says the speed v of an object in meters per second can be modeled given this square root equation. It tells us that Ke is the kinetic energy in joules. So normally when we see an equation, like K would represent something and E would represent something else, they're actually saying that this Ke is one variable, which is weird. Usually K is one variable, E is the other variable, we have 2 variables, but that's actually like one quantity. M is its mass in kilometers. Using a graphing calculator, or if you'd like to do it algebraically, you can. Find the kinetic energy for a 70 kilogram bicycle and rider traveling at a speed of 10 meters per second. So what variable do you think 70 represents? V, Ke, or M? M, good. So that means you're actually going to get rid of the M and replace it with 70. And the rider's traveling at a speed of 10 meters per second, so that's really our speed is V. Okay, so if you're doing this using the graphing calculator, you're going to have your y1, y2. If you're doing this algebraically, you're actually just going to set up an equation setting them equal. Remembering that Ke is just a variable together, one variable. Now if you're using the graphing calculator, you will have to use x. So it'll be square root of 2x divided by 70, and y2 would be 10. So pick one of those methods and go ahead and solve it out. Make sure you do attach appropriate units. So if you did it in the graphing calculator, originally when you press Zoom 6, your graph's going to look like this. You'll need to adjust, as you see, this is increasing at a very slow rate. You need to adjust your window and make the X max really big. I think I did it as like, I don't think even 1,000. Let's see if 1,000 works. No, 1,000 doesn't even work. So I think I just went crazy when I did this in first period. Said, let's just make it 10,000. So hopefully I don't have to come back to this window again and press our graph button. And then you do see them intersecting just at the very top. If you wanted, you could change your Y max, but you really don't need to. So second trace, intersect, line 1, line 2, and then your guess you will get as close as possible. You should get 3,500. Now what is the unit that we would attach to that based on the word problem? Sorry? Joules. So kinetic energy was in joules. If you did it algebraically, you should be getting the same thing. You would square both sides to get 100, multiply by 70 to get 7,000, and then divide by 2. Get 3,500 as well. Okay. So on your homework, I'll let you guys choose whichever way you'd like to do it. Obviously, I know many of you will find this way easier, but I would like you to still feel comfortable, at least, with doing it on the graphing calculator. Now, our last 2 questions ask us to rewrite a square root equation to make it easy to graph using transformations. Now we're not going to graph it, we're just going to describe the graph in words. But if you remember yesterday, we talked about all the transformations, the translations, shifting left, shifting right, up and down. And we talked about the number in front of the square root, which is a stretch or a shrink, depending on its value. We never talked about what happens if you have a number inside, okay? Because that's not a direct transformation. So what we're going to do is we're going to actually simplify this equation by factoring in square rooting to get it back into a normal looking transformation like yesterday's, because otherwise you cannot say that this goes to the left 18 and that it has a stretch of 9. That would be wrong, okay, because of the way that it's set up. So if you were to actually graph this without doing what we're about to do, you'd have to do an XY table. That's the only way you would be able to find out the values. So what we're going to do is we're going to look at the radicand, the numbers or expression underneath the radical, and we're going to try to simplify this by taking out a GCF. So the GCF between 9x and 18 would be 9. Now when I say factor it out, I'm still leaving it under the square root. I'm just factoring it out of each term. So I'd be left with x plus 2. Now since we have two things being multiplied now, 9 is being multiplied by the quantity x plus 2, we can break these up into separate square roots. Square root of 9 and the square root of x plus 2. And then we know the square root of 9 is 3. So the simplified equation is 3 times the square root of x plus 2. Then they ask us to describe the graph. Okay? So this is something now we could graph. We know that the parent function y equals the square root of x is being shifted 2 units, which direction? What was that? Left. Where's my 2? And then the 3 in the front tells us that it's being stretched. So we can say and is being stretched by a factor of 2. On the homework, if you want to shortcut that with like bullet points, like left 2, stretch 3, it's fine. The last one we have then is a cube root. We're going to do the same thing because again we have this 8 inside the cube root, which we don't know how to describe that. So again, we're going to go ahead and take out a GCF of 8. And then we know the cube root of 8 is just 2, so that would become an outside number. Now remember, this is a cube root, so that is the one that would look more like this. Okay. So we would want to, if we were describing this using words, say that the graph, the parent function, is just the cube root of x. Okay, so this is being shifted. The inside tells me 3 units to the right, and the outside tells me 3 units up. So this is being shifted 3 units right. And 3 units up. And being stretched by a factor of 2. Okay, I'm going to go over one of the closures with you because all of my classes were pretty much getting stumped, which is 74, and then I'm going to have you do the other 3 on your own. Okay, 74 says which equation shows this equation rewritten in this format. Okay, so it's kind of like what we did above, where we rewrote it using the forms. Now, just a note, all of the equations are in y equals. So we know that we would have to move the positive 3 over, right? So we'd have to subtract 3 on both sides. So you can automatically eliminate which answer choice? F. Okay, and I hate how they have a plus and negative, but we're just going to go with it. Now, another thing to notice about all the answer choices is that none of them have fractions under the square root. So what we're going to actually do with the radicand is I'm going to rewrite this using a common denominator. Common denominator between 16 and 1 is obviously 16. So I'm going to make this the square root of x over 16 plus 32 over 16. And then the minus 3 goes at the end. And the reason I'm doing this is that there's no fractions left, so I must be combining these or factoring out something. So just like we took out a GCF up here of an 8, we're actually going to take out a fractional GCF of 1/16. Now, when you take 1/16 away from x over 16, we're left with just x. Because that would get me, when I multiply back, x over 16. When I take 1/16 away from 32, what am I left with? 32. And if I were to redistribute that, I get 32/16, which is what I had before. And then the last thing that we can do is we can actually take the square root of 1/16. The square root of 1 is 1, and the square root of 16 is 4. So that's going to get me 1/4 times the square root of x plus 32 minus 3. And then we pick the answer choice that is closest to that because they have all their double signs. We have minus a negative here, which would turn to a positive, and plus a negative, which would be a minus. So our answer is H. See if you guys can try the other few. I don't know if we'll get to them before the bell. They're pretty quick. And then your homework is on my teacher page, since there's no graphs. So we'll be reviewing tomorrow and Thursday with your test on Friday. And then we are doing CETs next week on Monday and Tuesday. For anyone that did them, you should be getting A, J, and B for the first 3 weeks.